Breaking news: gravity, magnetism, and static electricity. How are they the same and how are they different?
Welcome back to Channel 21, where we still don't know the answer to 9 plus 10. Today, we are learning about the similarities and differences between gravity, magnetism, and static electricity. Reporter Aiden is currently in the field trying to find the answer to this question.
Thank you, Eli. Today I'm in the library to try to find this answer. Based on my research, gravity is caused by mass. This means the greater the mass, the greater the gravity.
Interesting.
Yep, it also affected by distance.
What does that mean?
It means the farther away you are from something, the less it will you're affected by gravity.
Huh. So the closer I am to, say, the Earth, the more it'll pull me down?
Exactly. Like you said, gravity is just a pull. Unlike magnetism, which do both.
Really? How?
Well, in atoms, there are tiny particles orbiting it called electrons. These electrons are in some materials, including iron, nickel, and cobalt, will attract and repel other electrons to its form to form domains like those of magnets.
That's really cool. But how do we know when they will attract or repel?
That's a good question. All magnets have a north and south pole. If you ever heard the saying opposites attract and likes repel, then you know exactly how magnets work. The north pole of a magnet will always push from another north pole, but always attract to another magnet's south pole.
Wait, but doesn't the Earth have a North and South Pole? And isn't that how compasses show you which way to go? I thought the North Pole of the compass pointed to the Earth's North Pole.
Yes, exactly. The Earth is just a big magnet. Though the answer to your second question is a bit more complicated. The north pole of the compass is the line of the geographical north pole. But the actual magnetic south pole, it can be a little bit more confusing sometimes, especially when the magnetic poles move.
It can move?
Yes, but 45 to 50 kilometers a year. Also, magnets have a field, this area around a magnet, in which other magnets can be attracted to it. This Earth magnetic field is very large, and it protects us from harmful radiation waves from the sun.
That's crazy. We'll be back after a short break.
What keeps your feet on the ground? Your balloons stuck to the wall and magnets snapping together. Gravity pulls, static electricity surprises, magnetism.
Pew, pew,
Welcome
pew,
back.
pew, pew.
Earlier we learned about magnetism and gravity. Now we have static electricity. Back to Aiden.
Just like magnetism, static is caused by electrons, except it isn't how they phase. It's how they travel between objects. It's also a push and a pull of affecting on all objects. Some examples of this are balloons on hair and lightning.
Thank you, Aiden. What were your sources?
Your nodes, NASA and University of Illinois.
In conclusion, the similarities and differences are that all three do not require contact to function, though some elements of static and magnetism do. Both static and magnetism push and pull, while gravity only pulls. Gravity and magnetism both play an important part in protecting us from the dangers of space. Both static and magnetism are caused in part by electron, though while magnetism is based on how they are facing, static is based on how they move from one object to the next. Until next time, when we still won't know the answer to 9 plus 10, and good night.